Okay, we are going through some homework problems on 5-9, and I just said, oh, let's probably record, just in case, and then you guys can always check your answer if you need to. That is not, there we go. Yep. So, starting with number 10, this is what he looks like. 1 minus x dx. Okay, all right, this is substitution, right? What did you pick as your u?
1 minus x.
1 minus x, okay. Then du will be, the 1 will go away, minus x will become -1 dx.
Yes.
Yeah? Okay, now I'm going to start substituting. So I've got my integral, so I'm going to leave him like this. So he's taken care of. This guy is going to become the square root of u. But then I have x dx that I need to replace.
1 minus u.
Yes, yes. Okay, so one more thing really quick. We have to, if I'm trying to get dx by itself, I'm going to divide by -1. And so I'm going to replace -1 du here. And that takes care of my dx. But then x, I have to look at this guy right here and solve for x there to figure out what I'm going to plug in for that. Okay, so like if I add this x over here, this would be like x plus u equals 1, right? If I add the x over. Then if I subtract u, x will be equal to 1 minus u. So that's what I'm going to plug in for here. 1 minus u is what that thing is. Okay. Now what? Now everything's substituted for. But now what? Not yet. I would simplify that guy in there real quick. First, this is u to the 1/2 power. I'm going to take him and I'm going to distribute him here and distribute him here.
Smart idea.
That's what I would do. So 1 times u to the 1/2 is u to the 1/2. Okay, minus, what about u to the first and u to the 1/2?
U to the
3 over 2, yep, yep. Okay, and I'm going to do this, since that -1 is just chilling, rather than having to deal with him later, I'm going to just drag him through and make that plus minus. I'll put that in a different color so we can look back on it and see. So minus, plus, and now I'm just doing the integral du. And I don't have to worry about the negative later. If it was a number, great, that would be better to worry about him later, but here I'm just going to do that now. Okay, this is disgusting. Gross. Blech. Okay. Antiderivative of this guy. You're adding 1 to the exponent, which is going to make him 3/2. So out in front, he'll be -2/3 u to the 3/2. Just like that. Good?
Yep.
Plus, if I add 1 here, that would be 5/2. So he will be 2/5 u to the 5/2. Okay, and then I'm going to plug numbers in. But do you guys like to do that method too where you switch them?
Yeah.
Okay, so -3 and 1 was what I was, or excuse me, -3 and 0 was what I was doing before. So here, if x is -3 and x is 0, u equals and u equals. Okay, all right, if x is -3, this would be 1 minus a -3 or 1 plus 3, which is 4. That's what he is. Okay, and then if x is 0, 1 minus 0 will be 1. So I'm going to plug in 4 and 1 instead of -3 and 0. Now, this looks really kind of funny, actually, because normally the bigger number goes on the top. And that's how it was with the x's, right? Like the bigger number, 0 was technically the bigger number, so it went on the top. But here, it just so happens that like when I switch it to u's, the bigger number is on the bottom. So we're still just going to do it like normal. We plug in the top number, subtract what we get when we plug in the bottom number. Okay, that's how that's all got to work. All right, so I'm going to plug in 1. I've got -2/3, 1 to the 3/2 plus 2/5, 1 to the 5/2. Okay, and that's going to come out a little bit nicer than we think. Minus what I get when I plug in 4. So -2/3, 4 to the 3/2 plus 2/5 times 4 to the 5/2. Boo. Okay. All right. Got all that stuff going on here. This is quite gross. All right. 1 to any power is just 1. So those go away. So I have negative 2/3 plus 2/5. And I am going to find a common denominator, 15. And I'm going to take this times 5 and this times 3. So negative 10 over 15 plus 6 over 15. Negative 4 over 15 is what I get for that guy. Okay, minus this junk. Okie doke. All right, this 2 means the square root of 4, and the square root of 4 is 2, and 2 to the 3rd power is 8. So this guy becomes 8, and negative 2/3 times 8 is negative 16/3. Yeah? Okay, the square root of 4 is 2, and 2 to the 5th power is 32, and 32 times 2 is 64 over 5. Oh, man. All right, I'm going to do my common denominator again of 15. So I'm going to take this times 5 and this times 3. So I've got 15s and I've got 15s. This is going to be negative 80. 16 times 5 is 80. This one, 64 times 3 is 180 plus 12, so 192. So that full thing is going to be 112 over 15 if I take negative 80 plus 192. And then we're subtracting that. So this guy is negative 116 over 15, which is, I don't know, something.
The whole answer is negative 8.4.
Negative 8.4. Perfect. That sounds about right. Yeah, gross. That was disgusting. Blah, 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 blah. I thought that was going to come out nicer than it did, but it didn't. But it didn't. Next is 32. Okay, 32. Let's check it out. This one might actually be a little bit nicer in comparison. It's going to be like a similar deal, but we don't have that x on the outside. So this one's going to be just a touch probably easier. U equals 5x minus 1. Du equals 5 dx. Okay, and the only difference here is that I'm going to have to divide by that 5. So I get 1/5 du equals dx because I don't have a 5 in my other stuff. So I've got my integral symbol. Okay, he's done. This is the square root of u, and then dx, this guy gets replaced with 1/5 du. That was kind of fast. Was that okay? Okay, so this is u to the 1/2 power, all right? And if I add 1 for my antiderivative, that's 3/2. So this will be 2/3 u to the 3/2. But I've got that 1/5 out there. So final antiderivative will be 2/15 u to the 3/2. Okay, and then we're going to plug stuff in, but let's switch our numbers first. Okay, here x was 1 and x was 2. We're going from 1 to 2, so let's figure out what u is. Okay, if I plug 1 in for x, 5 times 1 minus 1 is going to be 4. And if I plug 2 in for x, 5 times 2 is 10 minus 1 is 9. So we're going from 4 to 9 instead of 1 to 2. Oh, and guess what? Those are going to be so nice because we're doing square roots of 4 and 9, and those are going to be super. Okay, 2/15, 9 to the 3/2, minus 2/15, 4 to the 3/2. Okay, this guy means square root of 9, which is 3, and 3 cubed is 27, and 27 times 2 is 54 over 15. Huh. Minus the square root of 4 is 2, and 2 to the 3rd power is 8, and 8 times 2 is 16 over 15. So 54 minus 16 is that 38? 38 over 15, which is like 2.53. Perfect. That's what we get. Very nice. Now, if you guys are not into like solving anything in your head, you can abort mission at this point and type that into your calculator. That's fine. I understand it's a Friday, but anyway, so that's what he looks like. Okay, that's 32. That was a little bit better in comparison to number 10. Whew. Okay, 30, what are we at now? 38? 38 actually comes out really nice. I remember Reese doing this the other day, and she was like, yeah, this is fun. Okay, tangent, maybe she didn't say it was fun, but I said so, times secant squared x dx. Okay. What do you think you're going to use as your u? Tangent, yeah, because that's trapped, oh, I don't know why I put du. Tangent x is going to be your u because he's trapped underneath of the square root. Okay, now, guess what the derivative of tangent is? Secant squared dx. That is super nice. Okay, so I've got my integral. I've got the square root of u, and secant squared dx is now du. Super. So I've got u to the 1/2, and we've done this a bunch of times before, so 2/3 u to the 3/2, and then I've got to just plug my numbers in. So if x is 0 and if x is pi over 4, if x is 0, tangent of 0 is 0. Tangent of pi over 4 is, it's 1. 1, yep. It's a 45-degree angle. Sine and cosine at pi over 4 are both the square root of 2 over 2. So tangent is sine divided by cosine, so it's square root of 2 over 2 divided by square root of 2 over 2, so that's going to be 1. So I'm going from 0 to 1 instead of 0 to pi over 4, so that's super nice. 2/3 times 1 to the 3/2 minus 2/3 times 0 to the 3/2, and 0 to the 3/2 goes away, like that whole thing. 1 to the 3/2 is 1, so 2/3. Beautiful! Yeah. Okay, before I write down number 40, actually, I'm going to write it down, and then we're going to discuss, because Reese asked me this the other day, and I was actually quite puzzled. I don't know why I gave you this question.
Squared? 4 x, what?
Pi squared.
Pi squared.
And 4 pi squared.
But why?
1 over the square root of x sine of the square root of x dx. Why did I give you this dreadful, dreadful problem?
That's a good question.
Evaluate integrals by any method. Because if u is,
You don't like us.
I know, if u is the square root of x, then this would be sine of u, but then you'd still have that. And how do I take the antiderivative of both of those at the same time? I am a bit puzzled. The only other option is like doing integration by parts, which we haven't learned how to do yet. But I don't know what they're doing on number 40. Unless there's any other thing. I just don't see how, like, the derivative of one piece ends up showing up as, you know, the other one. Oh, maybe I do. Maybe I do. Hold on. Maybe I do. Ready? The square root of u. What's the derivative of x to the 1/2 power?
2/3. No, wait, that's backwards.
1/2 comes down. X to the negative 1/2 power, which is 1 over 2 square root of x dx. Yeah, that's it. That's how it works. Okay, but we don't have the 2 in the bottom. So we've got to bump the 2 to the other side.
It's just 2.
So we're going to multiply by 2, so 2 will go to the other side, right? And that will cancel him. So 1 over square root of x dx shows up there. Okay, so we've got it figured out. My integral symbol, this guy, 1 over the square root of x, he shows up here, 1 over the square root of x dx. So that's going to get replaced with du, but then I just have sine of u, right? And I need 2 out in front. That was a lot of weird substitution stuff. Okay, all right, I'm following now. We just had to think for a little bit, okay? What's the antiderivative of sine? I think it's negative cosine. The derivative of cosine is negative sine, so the antiderivative of sine is negative cosine. So 2, I'm going to go negative 2 cosine of u is my antiderivative. What?
Well, you just pull the negative goes to the cosine for your square.
Oh,
Yeah. The antiderivative of sine is negative cosine. So I just put the negative out in front. Yep, negative 2 cosine u, okay? And let's change our limits. So we were before going from pi squared. I know why I get the whole square now.
Just pi.
Do you understand the square now? U equals the square root of pi squared, and u equals the square root of 4 pi squared.
Which is 4.
No,
2 pi.
2 pi. 2 pi. So we're going from pi to 2 pi is my two things. This is super nice. Super nice. Okay, I'm thinking cosine, and cosine is the x coordinate. So I'm going to go, do you know where pi lives? Pi lives right here.
Outside?
Pi lives right here. And that coordinate is negative 1 comma 0. 2 pi lives here, and this is positive 1 comma 0. Okay, so just keep that in the back of your mind. We've got negative 2 cosine of 2 pi, whatever that comes out to be, minus negative 2 cosine of just regular pi. Boop. Okay. All right, cosine of 2 pi, this little piece right here, cosine at 2 pi, which is this guy, is the x coordinate.
Just 1.
So 1. This is 1. Negative 2 times 1 is negative 2. Minus, okay, cosine at pi is negative 1. Negative 1 times negative 2 is 2. So,
0.
nope,
No, it's negative.
negative 4. Oh, that one actually was not too bad. Like, that was the nicest answer we've gotten this whole time.
Yeah.
Really?
Well,
Yeah, like all the other ones were
The ones
decimals.
that we didn't
What
do
the
together,
heck?
yes.
Negative 4. That was nice. Okay, so yeah, we just got to think about it a little bit.
Yeah.
That was weird. I like it though. I like it a lot. I like it a lot. There you go. Okay, so there's homework problems. I don't know if you have questions on the first two, but those are the ones that we just
those
did.
are fairly
Okay,
nice.
perfect.